All right, so now we're in target 2.6. Can you compute percentage error? The fact is that when we do labs in lab, we have to deal with the fact that we may have Mark on our team. Mark on our team. What does that mean? Well, he is human. He's very human. Because he's very human, he will tend to make mistakes. We have to take into consideration the mark factor when we're doing lab, because everyone will have a mark in between them and their lab partners. There's always going to be one mark. All right, which means there's going to be a certain amount of error. A certain amount of error that's going to sneak in to the lab. We need to be able to account for that. So what we do is we calculate percentage error. We calculate percentage error. Percentage error is going to compare the real answer to the mark answer. The real answer to the mark answer. Now, before you copy this down, look at your best friend's butt around 6 o'clock. And what will you find there? There it is. Notice the difference between my equation here and the equation you have on your best friend's butt. What's the difference? Really? I thought I have observed minus true here, and it's true minus observed down there. Oh, it's the same thing? Okay, and if it was true minus observed, would it really matter? Why? Because absolute value would take care of that. Absolute value means it doesn't matter whether it's true minus observed or observed minus true. We're not going to get a negative number. That's right. Okay, so what is true? What is observed? Quite simply, observed is what Mark comes up with. True is what I say it is. Okay? True is the truth. Observed is what Mark comes up with. So what we're going to do is we're going to take Mark minus me and divide by me. Mark minus me and divide by me. All right. Get those calculators warmed up. Here we go. The accepted boiling point of ethyl alcohol is 78.4 degrees Celsius. What did I just tell you?
The truth.
That's the truth. Now, when Mark measures the boiling point of the alcohol, Mark records a temperature of 79.2 degrees Celsius. What's that? The observed. All right. 78.4 minus 79.2. Absolute value. Divided by what? Mark or me?
Me.
Times. All right. Click, 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 click. I want to see everyone clicking.
I got it, Steve.
What'd you get, Simon? Okay. Alex? Alec, what'd you get the answer? What is it? What? Close, but no cigar. Ryan?
2.4.
Definitely not.
24.
No.
No?
Okay, let's take out your calculators. Let's try this together. 78.4 minus 79.2. Hit enter. All right? Divide by 78.4, hit enter.
Negative 1.
Times 100. What is it?
Negative.
All right, and is this correct? Is Molly correct? No. What did Molly forget about?
Oh, she left it naked. It's doing porn.
No, percentage is definitely some clothing. Sig digs. Oh, you mean that we have to consider sig digs for this as well? Yes. Every time. 78.4. 78.4. 79.2. How many sig digs? So your final answer needs to be How about 1.02% since we're trying to find percentage error? All right, let's try this one. What is the Mark statement? What is the me statement? Mark minus me divided by me. Which one's me? Viet. What is it?
Oh, I did get it.
Did you round up or down? Is it 14.2? 14.2? Sig digs? Okay, is 14.2 the correct answer? Viet? Percent.
Porn.
No porn. No porn. Porn bad. Porn bad. All right. Look at the first three questions on worksheet 2.3. Notice that there are these kinds of questions. Set them aside. Hey, I can do this. All right. So let's go to the next target. Next target, you need to be able to convert F to Celsius, Celsius to F, Celsius to Kelvin, and Kelvin to Celsius. This can be found on pages 33 through 40. Why is Celsius so useful to us in science?
Ooh.
Ryan?
Because it's easy, because 0 is ice, 100 is boiling.
I think by ice you meant the freezing point of water. He's absolutely right. The most important chemical in our lives is water, and Celsius is attuned to water, where 0 is the freezing point of water, and 100 is the boiling point of water. Okay? So it makes sense to us. What is the conversion of F to Celsius? It's a little tricky. 3 steps. The first and second and third step, are going to be exactly the same. Plus 40, plus 40, minus 40, minus 40. Now, the question is, what's the second step? Any track people here? Mark, your track, you runner? Okay, so we're going to have Mark be Celsius. We're going to have Celsius start at the finish, at the starting line. F is his opponent. We're going to start F 32 meters ahead. You could almost say 32 degrees ahead. So F gets a head start of 32 degrees on Mark. The gun goes off, and here we go. And it doesn't take Mark very long to realize that F is about 2 times faster than he is. So not only does F get a 32-degree head start, but F is 2 times, about 1.8 times faster than he is. Will Mark ever catch up to F?
No.
He doesn't have a chance. So, if you're F, where can you always find Mark? Behind you. If you're Mark, where will you always find F? Actually, if it is really a race where you go round and round, eventually you're going to start seeing him behind you, because as you can imagine, every lap F is getting further and further away from him. So eventually he'll lap Mark. So if you're F and you're looking back, you divide by 1.8, because you're 1.8 times faster. If you are C, you're looking forward. Would you multiply or divide? Multiply, because F is 1.8 times faster. And that is how you convert from C to F and F to C. Marie. Just the way it was all calibrated when they came up with Celsius. Since F was 32, they made Celsius into 0. They literally designed it. They literally designed it so that 0 would be freezing point of water. And 100 was the boiling point of water, period. Now, how do we make it so that F equals C? And that's the formula they came up with. There's other ways of doing it, but I thought this was the easiest way because the first and the third steps are exactly the same. You just need to remember the number 1.8, and you need to remember the illustration of the race. F is always going to be higher, so you multiply. C is always going to be behind you, so you would divide. Alec? I don't know. It's just how mathematically it works. Not a clue. Not a clue.
Add 40 and then divide.
We will do some examples. Okay? Is an F degree equal to a C? In other words, is F equal to Mark? Can they run at the same speed? No. No. F runs a little bit faster. F's units are a little bit shorter. They're closer together. So the F degree will always get faster and faster, higher and higher. Why is Kelvin so useful? Max?
Because 0 Kelvin is absolute 0.
That's it. Can you have negative Celsius degrees? Yes. Can you have negative F degrees? Yes. Can you have negative Kelvin? No. 0 is as cold as anything can get. At 0, there is no heat. And temperature measures heat. So at 0, there is no heat. There is no negative numbers with Kelvin. And that is actually very useful when we get to gas laws. For the most part, we'll use Celsius, but when we get to gas laws, it has to be Kelvin in order to make sure that we have no negative numbers. Back to the race. Mark, at the starting line. Kelvin, I have good news for you. Kelvin runs as fast as you can. So you've got a shot this time. Unfortunately for you, Kelvin is always going to start 273 degrees ahead of you. But he runs the same speed. Will you ever catch up to him? Actually, you can pretty much count on that when the race is finished, you will be how many degrees behind? 273. Oh, dyslexic one. So, C to K, are you looking forward or behind? Forward. Add 273. K to C, are you looking forward or behind? Behind. You will find Mark 273 degrees below you.
Is that our buddy?
Nope. Don't put it there either. Needs to be up here.
Alright.
Nope. Hard to contain things in the heart. Try the brain.
Okay. What if I want to know it by heart?
Then I would suggest you know it by brain. The boiling point of water at the top of Mount Everest is 70 degrees C. Convert this. Okay, so that's Mark. 70 degrees Mark. Convert it to Kelvin scale. Where is Kelvin always going to be found? Ahead of you, ahead of Mark, or behind Mark? Okay, ahead by how much? Any questions? 77K, that's Mark's opponent. Where is Mark? By how much?
-196.
I don't know why, but when you're dealing with C and when you're dealing with F, you should put the little degree sign. But when you're dealing with K, you don't. Is that terribly important? No. But it is what it is. Okay? All right. 28 degrees C. Where will you find F? If Mark is at the 28 degrees C mark, where will you find F? Ahead of you or behind you?
Ahead of you.
Always ahead. Mark never wins. Mark never wins. Okay, so step number 1. Step number 1.
Add 40.
Add 40. So 28 plus 40 is 68. Step number 2, in order to make him ahead, multiply by 1.8. Okay, so what do we do now with decimals and stuff? Significant digits. Here's the rule for temperature. However many decimal places they give it to you, give it back to them in the same number of decimal places. So we don't have any decimal places, forget about the 122 point anything. Round up or down, it's 122. However many decimal places they give it to you, give the answer back in that many decimal places. Okay, final step. Either way, whether F to C or C to F, the final step is so 28 degrees C is 82 degrees F. One more. See if you can't figure this out on your own. I will be here quietly. What's 41 divided by 1.8? Agreed?